In problems 1 through 12, use the Laplace transform to solve the given system of differential equations. We are given d squared x over dt squared plus d squared y over dt squared equals t squared, and d squared x over dt squared minus d squared y over dt squared equals 4t. So the first thing I want you to acknowledge is that we are looking for x of t and y of t. Alright? Always helps when you know what you're looking for. So since this is a system of equation, we can use the rules we always use. And we're just gonna cancel out things and see what we're left with. So pretend like there's a plus sign here. So d squared x over dt squared plus d squared x over dt squared is just gonna be 2d squared x over dt squared. D squared y over dt squared minus d squared y over dt squared is just gonna cancel out. And t squared equals 4t is just gonna be equal to that. So once we have this, we want to isolate our d squared x over dt squared. And by the way, it looks a little daunting, but it's actually the same exact thing as x double prime. So divide by our 2, that's going to equal to d squared x over dt squared equals t squared plus 4t over 2. Now the next step is we have to invoke our Laplace transformation. To save time, I'm just going to write that as x double prime equals Laplace. And for this one, we're actually going to separate it into 2 pieces. So we're going to do t squared over 2 plus 4t over 2, which can just be simplified to 2t. And we're doing this because when we use our rules up here, it's going to be a whole lot easier. So what is the Laplace transformation of x double prime? Well, it's something you should have memorized. It will equate to s squared x of s minus s x of 0 minus x prime of 0. For t squared over 2, we are going to have to invoke this top rule up here. So how should we do that? Laplace of t squared over 2. So because it will be easier to just work with t squared, we're actually going to bring this 1/2 out, like that. And then in the middle, we can just leave t squared. So whatever our exponent is going to be n. So n is going to equal to 2 here. And then we're just going to plug into, we're just going to plug into to wherever we see n. That means we're going to have 2 factorial over s 2 plus 1, which will just equal to 3. And then remember, so 2 factorial just means 2 times 1. And then 2 times 1 is just 2. And then we have to bring back our 1/2. And that's just going to equal to 1 over s 3. So we can write our 1 over s to the 3. And then we're going to cross that out. Now for our 2t. It's going to be pretty similar. We're going to have our Laplace, 2t. We want to take the 2 out, so we're just going to put a 2 in front and erase it, so we just have t. And remember, every variable has an invisible exponent of 1. So n is going to equal to 1 here. And then we just plug in 1 for where we see. 1 factorial, which is just equal to 1. And then s 1 plus 1, which is just 1 over s squared. And then multiply by our 2 that we have here. That's just equal to 2 over s squared. 2 over s squared. So once we're here, we want to look at our initial conditions. X of 0 equals 8. X prime of 0 equals 0. X prime of 0 is just going to go away. We just have to put an 8 in there. So that's going to equal to s squared x of s minus 8s equals 1 over s to the 3rd plus 2 over s to the 2. And our goal right now is to isolate the x of s. So we're going to move the 8 to the other side by adding 8s. And then just divide by s squared on these sides. We can just add the powers of our exponents and it will equal the same thing. So 1 over s3. So let's look at our exponents. S to the 3 and s to the 3 and s to the 2. 3 plus 2 is 1 over s to the 5. So that's our first thing out. S to the 2 plus s to the 2. Remember, we're going to keep our numerator the same, s to the 4. And then that's just going to be plus 8s over s2. And those s's will cancel out. And then we're just going to have 8 over s and then x of s. So now that we have x of s, we can find x of t. Because x of t is equal to the inverse Laplace of x of s. Let's bring down our Laplace rule. The inverse Laplace of 1 over s to the 5th. Our bottom exponent is 5. So in order to find n, we can just set 5 equal to n plus n. And minus 1, n is going to be equal to 4. So just plug in 4 for all the n's. So it's going to be 4 factorial s 4 plus 1 is going to be equal to 5. The problem is what we have over here does not match to here. So in order to make a match, we have to multiply this by 1 over 4 factorial. And multiplying by 1 over 4 factorial is the same as dividing by 4 factorial, but it looks easier and more clear this way. So those will cancel out. It's going to be left with 1. Now that we acknowledge we have to divide by the 4 factorial, this right here will just be equal to t to the 4. Because, like I said, our n was equal to 4. And then don't forget to divide by the factorial. That's our first term. So now we have to do, let's cross out this term. Now we have to do 2s4. Let's put the 2 on the outside. So we have 1 over s4 here. To find our n, 4 equals n plus 1. And our n is going to be 3. So 3 factorial over s to 3 plus 1, which is 4. Now remember, we want it to match what we have in here. So we can't forget to multiply 1 over 3 factorial. And this will yield to t to the 3 over 3 factorial. And don't forget the 2, and it's going to equal to 2 t to the 3 over 3 factorial. And that is our second term. Now all we have is 8s. And for this is really easy. The inverse Laplace is literally what we see in the numerator. So it's just going to be 8. And that's x of t. That's half the problem done. So now we have to solve for y over t. But like we saw earlier, these will cancel out. So how do we stop them from happening? We have to multiply this by -1. So essentially just inverse the signs. So that's going to turn negative, that's going to turn positive, that's going to turn negative. So now we're going to add them together. So these will cancel. These will turn to just 2d squared y over dt squared. And it's going to equal to t squared minus 4. Like we solved the last problem, since, yeah, I'm just going to do the shortcut because I already showed you guys. T squared over 2 minus 2t. So now we have to find the Laplace. And we already know the Laplace of that. And the Laplace for y is just going to be the same thing we had for x, but with a y instead. So our initial values for y are both 0. So these will just cancel out. So, and then we're going to divide both sides by s to the squared. It's going to be y of s equals just to 1 s to the 5th minus 2 s to the 4. And now we just do the inverse Laplace. And if you remember, these are the same numbers we had for x. So our y of t is just going to be t to the 4 over 4 factorial minus, that's the only difference we're going to have, is that it's a minus 2t3 over 3 factorial, and that's it. Thank you for watching.